So here they're showing you we're showing you an experiment where we're detecting things in female urine. This is an experiment done in mice, and it shows you that those neurons from the accessory olfactory system are responding to something in the female urine. So here we're showing you when we've exposed the neurons to the female urine in this time. And then here we're looking at action potentials coming off a chunk of this tissue. So many different neurons are in there, and you can see that some are firing early, but really when you expose them to the female urine, then they start firing much more rapidly. And so this is a single trace from one piece of tissue. You can also show this for many pieces of tissue where if there's a lot of these peaks together, you just indicate that with this black signal, and if there's fewer, there's just a couple of stripes there. So it's the same information but now repeated over several different preparations. And if you average that, you get this averaged graph of as time goes by and we're showing them the urine, now they start to fire. You take the urine away and the firing decreases again. So they're really responding to something in that peak. They've done that with female urine, and then they see that if you use more concentrated urine, those purple bars, you get stronger response. As you start diluting it, the response goes away until the neurons are unable to detect enough of whatever chemical it is that they see to even fire. And here's the male urine that really doesn't elicit a response. So it's specific to pea and female mice that these neurons are firing. And these neurons come from male mice, so that makes sense, right? Now, if we do experiments to test the effect of this TRPC channel, we're going to delete the TRPC channel and do similar experiments. We're going to offer these mice the pea or some other way of exposing them to the signal, and then we're going to look at how they behave if they're wild type or if they are a mutant. So they've looked at male aggression, so these are now no longer preparations in a dish, but we're looking at actual mice and how they behave towards each other. Male aggression and male sexual behavior. And then what they do is they take male mice and castrate them. So they are no longer making male pheromones. And other male mice are not as aggressive towards them, but then they paint them with normal male pee. So now we bring some of those pee pheromones back onto the mice that normally don't really give you a response. So do you all understand what is depicted in these pictures? Which mice are here in the bottom here? Which are those plus pluses and the plus minuses and the minus minuses? Does it make sense to understand what's on the axes before we think about what we see? So are these the mice with and without P, or are these the mice with and without the receptor? The channel, I should say. The channel mice? Right, these are the receptor knockout mice. So we have wild type mice here, mice having one functional copy, and mice having no functional copy. So these are knockout mice. They don't have the TRPC channel. They're unable to process information in their accessory olfactory system. So if you give a wild type mouse one of those castrated males, the average attack frequency is what, close to 3? But if you take that same wild type mouse and you give it the same castrated male, but you paint it with urine that has a lot of male pheromones, now we start to see aggressive behavior. Right? This is what normally happens. Males don't like being in the same cage. They'll fight, often to the death. So they only will not do that if they're brothers and they've been raised together. This is what we do when we grow our mice for our experiments. If they're not raised together, you never put males together because they fight and it gets really nasty. I've seen like pieces of skin ripped off this big. They get really mean. If you have One of those copies missing, so you can imagine having lower levels of this channel that processes information from pheromones. We can maybe see a decrease already in the aggressive behavior, but if we knock out all together, there will be zero aggressive behavior towards the males, whether or not there's urine painted on them. Right, so let's take 2 minutes and talk yourself and your neighbor through this one. The X will be the same, but we're looking at a different behavior. What is our interpretation of this graph here?
Is the wild type the one where it's not castrated and not painted with urine, right?
I think the wild types are the ones either plus or plus minus.
No, I'm aware, but they're not castrated, right?
Oh yeah.
Not castrated and don't have extra male. They're just normal.
Well, that's the white one.
Yeah.
And then the black one is the plus. Is it male hormones? So the one on the right, it looks like the wild type has less of a sexual behavior, and the one that can't smell has more of a sexual behavior. Is that what it's saying? Average mounting frequency by males.
Yeah. Why would it increase the sexual behavior though? Or I guess if you can't smell.
Well, that's why
So you're just always
they're mounting other males.
so like they okay.
Is that what it's saying?
Yeah. Because it can't tell if it's female
That
or
is,
not because
yeah.
and then also can't smell the
Mhm. And then if they can't smell, then they know for sure it's male because they smell like a male.
So they're not going to be
So then there's no sexual behavior.
Alright,
For what
let's
class?
give us their interpretation
I
of
need the
the
email
graph.
back.
What's going on the right?
Take it back.
And maybe first talk us through what actually is depicted. What do we see? So who are listed here? Who's this? Wild type mice. And so can they smell or detect the pheromones? Yes or no? Yes, they can, right? Are they showing any sexual behaviors towards those castrated males? Nothing. They're not interested. If you have only one receptor or one channel, still nothing, right? But what happens if you have no channel, no information coming through this accessory olfactory system? We're starting to say, right? They don't see this animal as something that is not interesting for this kind of behavior because there's no reproductive advantage. Right? And so it doesn't matter if there's urine painted on them or not, they can't smell the difference. I mean, this looks different, but if you look at the error bars here, so I don't think these two treatments are any different. But can we now say that they've changed their sexual orientation somehow? Not really, right? Because we don't know how they'll behave towards females. Right? That's not in the graph, so we can't just extrapolate away and say that they've totally changed their behavior. So they did an additional experiment, and this is mice making noises to indicate that they're interested in mating. So these are ultrasonic vocalizations, and now the organization of the axis is slightly different, so let's take that into account. Now the color of the bar indicates the genotype of the guys that we're interested in, and we have here how they behave towards females castrated males or castrated males with urine painted on them. And so now we actually see that they are also still interested here, this white bar. They're as interested as the wild type mice in the females. We're still talking to them and saying, I like you, I like you. And then while the wild type males, those black bars, show no interest in the castrated males, again here we see that these knockout mice have no distinction, so they would like them equally well. I'm not sure that if this is going to be significantly different, but definitely they show an interest, whereas the wild type mice are not showing an interest. All right, so for these following statements, we maybe have time to go over one. Indicate if the experiments that we just talked about support this or disprove it or doesn't give us enough information. So the lack of the trypsin receptors resulted in these male mice becoming homosexual. I think we've seen that is not true, right? They're just interested in anybody because they have no longer the distinction between male and female. Lack of TRPC2 receptors, hey, I heard this either, resulted in animals that could not discriminate between males and females. That seemed to be very true. And see, these experiments show that male mice will mount anything in front of them, except if there's some chemical that they can detect through their accessory olfactory system that tells them actually wishes. What do you think?
I got it.
So here, everybody's happy to talk to the girls. It's not quite true, right? We see these wild type mice are also not interested in the castrated males. So either there's other pheromones or other signals that don't require TRPC2, or pheromones aren't all there is to explain this behavior. I think the authors of the paper really like the idea of 1C, but not quite true. All right, that will be it for this part of today.
It's funny because